Beneath the icy crusts of distant moons, hidden oceans stir, whispering secrets of potential life. We're not talking about a single ocean, but multiple, each one a tantalizing mystery tucked away in the outer solar system. From Europa's vast, salty sea to Enceladus geysers erupting with life-giving potential, and even Pluto's heart-shaped glacier hinting at a subsurface ocean, we're on the brink of a collective discovery that could rewrite our understanding of life in the universe. So, buckle up, because we're diving deep into the hidden oceans of the outer solar system, where every discovery brings us one step closer to answering that age-old question: are we alone? The icy giants, Jupiter and Saturn's frozen moons. Beneath the icy crusts of several moons orbiting Jupiter and Saturn, scientists have discovered vast subsurface oceans. These hidden bodies of water, kept liquid by tidal forces and internal heat, have sparked immense interest in the scientific community. Europa, one of Jupiter's largest moons, is believed to have an ocean beneath its icy surface, potentially containing more than twice the amount of water found in all of Earth's oceans. This moon's smooth, cracked surface suggests a dynamic interaction between the icy crust and the underlying ocean. Similarly, Ganymede, Jupiter's largest moon, is thought to harbor a substantial subsurface ocean sandwiched between layers of ice. Its magnetic field, detected by the Galileo spacecraft, hints at a conductive, salty ocean. Saturn's moon Enceladus has also captured the imagination of scientists and the public alike. Geysers of water vapor and ice particles erupt from its south polar region, providing strong evidence for a subsurface ocean. These geysers, first observed by the Cassini spacecraft, contain organic compounds, adding to the intrigue about potential habitability. Another of Saturn's moons, Titan, possesses a complex chemistry involving hydrocarbons and may have a subsurface ocean of liquid water and ammonia. Its thick atmosphere and Earth-like features, such as dunes and lakes, make it a fascinating subject of study. The collective discovery of these oceans has opened up new avenues for exploring the potential for life beyond Earth. The presence of liquid water is a crucial ingredient for life as we know it. On Earth, life thrives in even the most extreme environments, from deep-sea hydrothermal vents to icy polar regions. The subsurface oceans of these moons, shielded from harmful radiation by their icy crusts, could provide similar refuges for life. Microbial life, in particular, could potentially survive in these environments, drawing energy from chemical reactions in the absence of sunlight. The study of these moons not only broadens our understanding of the solar system, but also challenges our definitions of habitability and the limits of life. As our exploration of the outer solar system continues, the icy giants and their frozen moons remain at the forefront of scientific inquiry. Missions like the Europa Clipper, set to launch in the near future, aim to gather more data about these enigmatic worlds. By studying the composition, dynamics, and potential habitability of these subsurface oceans, scientists hope to uncover the secrets they hold. The journey to understand these hidden oceans is a testament to human curiosity and our relentless pursuit of knowledge. Each new discovery brings us one step closer to answering the age-old question: are we alone in the universe? A dance with Europa, Jupiter's enigmatic moon. Beneath the icy crusts of several moons in the outer solar system, scientists have found compelling evidence of subsurface oceans. These hidden bodies of water, often kept liquid by the gravitational tug-of-war with their parent planets, have sparked immense interest in the search for extraterrestrial life. Among these, Europa, one of Jupiter's largest moons, stands out as a prime candidate. Its surface, crisscrossed with dark streaks and cracks, suggests a dynamic interplay between the icy shell and the ocean beneath. The presence of these features, along with the moon's global ocean, makes Europa a tantalizing target for astrobiologists. Europa isn't alone in this dance of potential habitability. Ganymede, another of Jupiter's moons, is the largest moon in the solar system and also harbors a subsurface ocean. Unlike Europa, Ganymede has a magnetic field, which provides clues about the composition and dynamics of its hidden ocean. Further out, Saturn's moon Enceladus has geysers of water vapor and ice erupting from its south polar region, directly sampling the subsurface ocean for scientists to study. These plumes contain organic compounds, hinting at the potential for life. Titan, Saturn's largest moon, also has a subsurface liquid layer, but in this case, it's not water, it's hydrocarbons. This moon's complex chemistry and potential for prebiotic conditions make it a fascinating study in the diversity of habitable environments. The collective discovery of these oceans has reshaped our understanding of where life might exist beyond Earth. Each moon offers a unique laboratory for studying the conditions necessary for life. Europa's ocean, for instance, is thought to be in direct contact with a rocky seafloor, a scenario that could provide the necessary ingredients for life as we know it. The energy from tidal forces and potential hydrothermal vents could create environments similar to those found in Earth's deep-sea vents, where life thrives. Meanwhile, Enceladus geysers provide a direct sample of its ocean, allowing scientists to analyze its composition without even landing on the surface. These discoveries have fostered a sense of shared excitement and collaboration among researchers as they work together to unravel the mysteries of these distant worlds. The search for life in these hidden oceans is not just a scientific endeavor. It's a journey of collective discovery. Each new finding, each tantalizing clue, brings us one step closer to answering the age-old question: are we alone in the universe? The outer solar system, with its icy moons and subsurface oceans, offers a wealth of opportunities to explore this question. As we continue to study these enigmatic worlds, we are not just looking for water. We are looking for the potential for life, for the possibility of a second Genesis. And in doing so, we are not just exploring the outer solar system. We are exploring the very nature of life itself. The tides of Titan, Saturn's mysterious moon. Beneath the icy crusts of several moons in the outer solar system, scientists have found compelling evidence of subsurface oceans. These hidden bodies of water, often kept liquid by the gravitational tug-of-war with their parent planets, have sparked immense interest in the scientific community. Among these, Saturn's moon Titan stands out, not just for its Earth-like features, but also for the tantalizing possibility of harboring life. Titan's ocean, hidden beneath a thick ice shell, is thought to be in contact with a rocky core, creating a complex chemical environment. This interaction could potentially provide the necessary ingredients for life as we know it. Titan isn't alone in this intriguing club. Jupiter's moon Europa, for instance, is believed to have a global ocean beneath its icy surface, possibly with more water than all of Earth's oceans combined. Ganymede, another of Jupiter's moons, and Enceladus, a smaller moon of Saturn, also join this exclusive group. Each of these moons presents a unique environment, but they all share a common thread: the potential for habitability. The presence of liquid water, a key ingredient for life, along with the possibility of chemical energy sources, makes these moons prime targets in the search for extraterrestrial life. The study of these subsurface oceans is a collective endeavor, involving scientists from various disciplines and countries. Spacecraft like Cassini, which orbited Saturn for over a decade, and the upcoming Europa Clipper mission, have provided and will continue to provide invaluable data. Researchers analyze this information, piecing together the puzzles of these distant worlds. They use models to understand the dynamics of these oceans, the composition of their ice shells, and the potential for hydrothermal activity. Each discovery, each new piece of data, brings us closer to understanding these enigmatic worlds and their potential to host life. The search for life in these hidden oceans is not just about finding extraterrestrial organisms. It's also about understanding the origins of life on Earth and the potential for life elsewhere in the universe. The more we learn about these moons, the more we realize that our solar system is full of surprises. The tides of Titan, the geysers of Enceladus, the hidden oceans of Europa and Ganymede. All these point to a solar system that is far more dynamic and potentially habitable than we once thought. The journey to uncover these secrets is ongoing, and each step forward brings us closer to answering one of humanity's oldest questions: are we alone in the universe? Enceladus, a tiny moon with a big secret. Beneath the icy crusts of several moons in the outer solar system, scientists have found compelling evidence of subsurface oceans. These hidden bodies of water, often kept liquid by the gravitational tug-of-war with their parent planets, have sparked immense interest in the scientific community. Among these, Enceladus, a tiny moon of Saturn, has emerged as a fascinating subject of study. It harbors a global ocean beneath its icy surface, and plumes of water vapor and ice particles spew from its south polar region. These plumes, first observed by the Cassini spacecraft, contain organic compounds, hinting at the potential for life. The discovery of these subsurface oceans has opened up new avenues for astrobiological research. Enceladus, with its geysers and organic-rich plumes, is a prime candidate for hosting life. The presence of hydrothermal activity on its ocean floor, inferred from Cassini data, suggests that Enceladus has the necessary ingredients for life as we know it: water, energy, and organic molecules. Moreover, the moon's ocean is in direct contact with its rocky core, providing a source of minerals and energy that could support microbial life. The collective effort of scientists worldwide has been instrumental in unraveling these secrets, with each new discovery building upon the last. Other moons in the outer solar system also harbor subsurface oceans, each with its unique characteristics. Europa, one of Jupiter's largest moons, is thought to have a global ocean beneath its icy surface, possibly with more water than all of Earth's oceans combined. Ganymede, another Jovian moon, is the largest moon in the solar system and has a subsurface saltwater ocean, likely sandwiched between layers of ice. Titan, Saturn's largest moon, is known for its dense atmosphere and methane lakes, but it also harbors a subsurface liquid layer, possibly a mix of water and ammonia. The collective exploration of these moons has revealed a solar system teeming with hidden oceans, each a potential cradle for life. The search for life in these subsurface oceans is an ongoing endeavor, with future missions planned to explore these icy worlds in greater detail. NASA's Europa Clipper mission, set to launch in the coming years, will conduct detailed investigations of Europa's ice shell, ocean, and potential habitability. Similarly, ESA's JUICE mission will explore Ganymede, Europa, and Callisto, providing valuable insights into these icy moons. As our understanding of these worlds grows, so too does our appreciation for the potential diversity of life in the universe. The collective discovery of these hidden oceans has not only expanded our knowledge of the solar system, but has also fueled our imagination about the possibilities of life beyond Earth. The subsurface sea of Ganymede. Beneath the icy crust of Ganymede, Jupiter's largest moon, scientists have uncovered a vast subsurface ocean that could hold more water than all of Earth's oceans combined. This hidden sea, nestled deep within the moon's interior, is a testament to the dynamic and complex nature of our outer solar system. Ganymede's ocean is believed to be sandwiched between layers of ice, with the top layer being a thick, solid crust and the bottom layer potentially interacting with the moon's rocky core. This unique structure raises intriguing possibilities for the existence of life, as the interaction between water and rock could provide the necessary ingredients for chemical reactions that might support life. Ganymede isn't alone in its subsurface aquatic secrets. Europa, another of Jupiter's moons, is thought to harbor a global ocean beneath its icy surface. The evidence for Europa's ocean comes from observations of its cracked and jumbled surface, which suggests the presence of a subsurface sea that could be in contact with a rocky seafloor. This interaction could create hydrothermal vents, similar to those found on Earth's ocean floors, which are known to support diverse ecosystems. The potential for such environments on Europa has sparked considerable excitement among scientists searching for signs of extraterrestrial life. Enceladus, a tiny moon orbiting Saturn, has also revealed compelling evidence of a subsurface ocean. Plumes of water vapor and ice particles spewing from its south pole have been analyzed by the Cassini spacecraft, revealing the presence of organic molecules and salts. These findings suggest that Enceladus's ocean is not only liquid but also in contact with a rocky core, providing the necessary conditions for complex chemical interactions. The discovery of these plumes has been a game-changer, offering a tantalizing opportunity to study the composition of Enceladus's ocean without the need for a lander. The collective discovery of these subsurface oceans has transformed our understanding of the outer solar system. It has opened up new avenues for exploration and has fueled the hope that life might exist beyond Earth. Each of these moons presents a unique set of conditions that could potentially support life, from the vast ocean of Ganymede to the dynamic plumes of Enceladus. As we continue to explore these icy worlds, we edge closer to answering one of humanity's most profound questions: are we alone in the universe? Callisto, a silent witness to hidden depths. Beneath the icy crusts of several moons in the outer solar system, scientists have found compelling evidence of subsurface oceans. These hidden bodies of water, often kept liquid by the gravitational tug-of-war with their parent planets, have sparked immense interest in the scientific community. Among these celestial bodies, Callisto, one of Jupiter's largest moons, stands out as a silent witness to these hidden depths. Its ancient, cratered surface tells a story of stability and resilience, while beneath lies a secret that could rewrite our understanding of life in the universe. Callisto's subsurface ocean, inferred from measurements of its magnetic field and gravitational interactions, is thought to be buried beneath a thick icy shell. This ocean, if it exists, would be unlike any on Earth, potentially briny and sandwiched between layers of ice. The absence of tidal forces, unlike its more famous neighbor Europa, means Callisto's ocean is likely calm and undisturbed. This stability could provide a unique environment for the emergence of life, shielded from the harsh radiation that bombards the surface. The potential for life in such an environment hinges on the presence of essential elements and a sustainable energy source, both of which remain subjects of ongoing research. The search for life in these hidden oceans is a collective endeavor, involving missions like NASA's Europa Clipper and ESA's JUICE, Jupiter Icy Moons Explorer. These missions aim to gather more data on the composition and dynamics of these subsurface oceans. Callisto, with its relatively undisturbed surface, offers a unique opportunity to study a potentially pristine environment. The data collected could provide insights into the potential habitability of these moons and the broader implications for life in the outer solar system. The journey to uncover these secrets is not just about finding water. It's about understanding our place in the cosmos and the potential for life beyond Earth. The outer solar system is a treasure trove of icy moons with subsurface oceans, each offering a unique perspective on the potential for life. Ganymede, Jupiter's largest moon, is thought to have a subsurface ocean that could contain more water than all of Earth's oceans combined. Enceladus, a tiny moon of Saturn, spews water vapor and ice particles into space, providing direct samples of its subsurface ocean. Titan, another Saturnian moon, has a complex chemistry that includes liquid hydrocarbons on its surface and possibly a subsurface water ocean. Each of these moons contributes to the growing body of evidence that subsurface oceans are common in the outer solar system. The collective discovery of these hidden depths fuels our imagination and drives our quest to explore the final frontiers of our solar system. The Dwarf Planet Ceres, a miniature ocean world. Nestled in the asteroid belt between Mars and Jupiter, Ceres, the largest object in the main asteroid belt, harbors a secret that has captivated scientists and space enthusiasts alike. This dwarf planet, though small, is a miniature ocean world, with evidence pointing to a vast reservoir of briny water beneath its icy surface. The discovery of bright spots in a crater, which turned out to be deposits of sodium carbonate and other salts, has fueled speculation about the presence of liquid water. This finding has significant implications for the potential habitability of Ceres, as liquid water is a key ingredient for life as we know it. Beyond Ceres, the outer solar system is teeming with moons that harbor subsurface oceans, each offering a unique environment that could potentially support life. Europa, one of Jupiter's moons, is covered in a thick layer of ice, but beneath this frozen surface lies a global ocean of liquid water. The tidal forces exerted by Jupiter's massive gravity keep Europa's ocean liquid, and the moon's geologically active surface suggests that nutrients from the interior could be mixing with the ocean, creating a potentially habitable environment. Similarly, Ganymede, another of Jupiter's moons, is believed to have a subsurface ocean sandwiched between layers of ice, with a complex interplay of salts and possibly even a magnetic field generated by the ocean's interactions with Jupiter's magnetosphere. Enceladus, a tiny moon of Saturn, has become one of the most promising candidates for hosting life beyond Earth. This small moon spews geysers of water vapor and ice particles from its south polar region, which originate from a subsurface ocean. The Cassini spacecraft detected complex organic molecules in these plumes, hinting at the possibility of hydrothermal activity on the ocean floor. Such activity could provide the energy and nutrients necessary for life to emerge and thrive. The collective discovery of these ocean worlds has sparked a sense of excitement and wonder as scientists and the public alike contemplate the possibility of finding life elsewhere in our solar system. The search for life in these hidden oceans is not just a scientific endeavor, but a collective journey of discovery. Each new finding, each tantalizing clue, brings us one step closer to answering the age-old question: are we alone in the universe? The dwarf planet series and the moons of the outer solar system offer a wealth of opportunities for exploration and study. As we continue to unravel the mysteries of these miniature ocean worlds, we edge closer to understanding our place in the cosmos and the potential for life beyond Earth. The journey is just beginning, and the possibilities are as vast as the oceans hidden beneath the icy surfaces of these distant worlds. The mysterious moons of Uranus. Nestled in the frigid expanse of the outer solar system, Uranus and its entourage of moons offer a tantalizing glimpse into the potential for life beyond Earth. Among these moons, 5 stand out due to their potential subsurface oceans: Miranda, Ariel, Umbriel, Titania, and Oberon. These icy bodies, far from the sun's warmth, harbor secrets beneath their frozen surfaces. Scientists believe that tidal forces from Uranus' gravity could generate enough heat to melt ice into liquid water, creating vast oceans hidden beneath their crusts. The presence of these oceans raises intriguing questions about the possibility of life. Miranda, the innermost of these moons, is a world of stark contrasts. Its surface is a patchwork of ancient, heavily cratered terrain and younger, icy plains. The moon's unique features, such as massive cliffs and canyons, suggest a complex geological history. Ariel, the brightest of Uranus' moons, shows signs of past geological activity, with smooth plains and extensive systems of ridges and valleys. These features hint at a subsurface ocean that may have driven cryovolcanic activity, spewing water and ammonia into space. Umbriel, on the other hand, appears more dormant, with a dark, heavily cratered surface. However, its relatively high density suggests it may have a rocky core surrounded by a mantle of ice and a possible subsurface ocean. Titania, the largest of Uranus' moons, and Oberon, its second largest, present even more compelling evidence for subsurface oceans. Both moons show signs of past geological activity, with extensive systems of canyons and faults. Titania's surface is a mix of old, heavily cratered terrain and younger, icy plains, while Oberon's surface is dominated by ancient, dark terrain interspersed with bright impact craters. The presence of canyons and faults on both moons suggests that their interiors may have been warm enough to support subsurface oceans. These oceans, shielded from the harsh radiation of space, could provide a stable environment for life to emerge and thrive. The search for life in these hidden oceans is a collective endeavor, driven by our insatiable curiosity and technological advancements. Scientists use a combination of ground-based observations, spacecraft data, and theoretical models to study these distant worlds. Future missions, such as NASA's proposed Uranus orbiter and probe, could provide unprecedented insights into the composition and dynamics of these moons. As we continue to explore the outer solar system, we edge closer to answering one of humanity's most profound questions: are we alone in the universe? The mysterious moons of Uranus, with their hidden oceans, offer a tantalizing clue that we may not be. Ariel, a moon with a hidden heart. Beneath the icy crusts of several moons in the outer solar system, scientists have found compelling evidence of subsurface oceans. These hidden bodies of water, nestled beneath the frozen surfaces, have sparked immense interest in the scientific community, particularly in the quest to find extraterrestrial life. Among these intriguing worlds, Ariel, one of Uranus' moons, stands out due to its potential to harbor a subsurface ocean. Ariel is not alone in this regard. Other moons, such as Europa, orbiting Jupiter, and Enceladus, orbiting Saturn, have also been identified as potential candidates for hosting subsurface oceans, making them prime targets in the search for life beyond Earth. The discovery of these subsurface oceans is a testament to our collective curiosity and technological advancements. For instance, Europa's ocean is believed to contain more than twice the amount of water found in all of Earth's oceans combined. This staggering volume of water, combined with the presence of essential chemical elements, creates a potentially habitable environment. Similarly, Enceladus has geysers that spew water vapor and ice particles into space, providing direct samples of its subsurface ocean for analysis. These findings have fueled speculation about the possibility of microbial life existing in these extreme environments. Ariel, though less studied than Europa or Enceladus, shows promising signs of a subsurface ocean. Its relatively young and bright surface suggests recent geological activity, which could be driven by the heat generated from tidal forces exerted by Uranus. This heat could maintain a liquid ocean beneath the moon's icy crust. The presence of such an ocean would make Ariel a compelling candidate in the search for life. The collective effort to study these moons involves a combination of spacecraft missions, ground-based observations, and theoretical modeling. Each new piece of data brings us closer to understanding the potential habitability of these distant worlds. The search for life in these subsurface oceans is not just about finding microbial organisms. It's about understanding the limits of life and the conditions under which it can thrive. The discovery of life in these extreme environments would have profound implications for our understanding of biology and the potential for life elsewhere in the universe. As we continue to explore these hidden oceans, we are not just looking for water. We are looking for answers to some of the most fundamental questions about our place in the cosmos. The journey is as exciting as the destination, and each new finding brings us one step closer to unraveling the mysteries of these enigmatic worlds. Umbriel, the enigmatic ice moon. In the frigid expanse of the outer solar system, a collection of icy moons orbit gas giants, hiding secrets beneath their frozen surfaces. Among them, Umbriel, a moon of Uranus, stands out as an enigmatic world. It is part of a growing list of celestial bodies suspected to harbor subsurface oceans. These hidden oceans, nestled beneath thick layers of ice, have sparked considerable interest in the scientific community. They represent potential habitats for extraterrestrial life, offering protection from harsh radiation and extreme temperatures. Umbriel's relatively dark surface and ancient, heavily cratered terrain hint at a history of geological inactivity. Yet, the possibility of a subsurface ocean adds a layer of intrigue to this seemingly dormant world. Umbriel is not alone in this regard. Several other moons in the outer solar system share similar characteristics. Europa, one of Jupiter's moons, is perhaps the most well-known example. Its icy surface is crisscrossed by long, linear fractures, suggesting the presence of a subsurface ocean. Enceladus, a moon of Saturn, has geysers that spew water vapor and ice particles into space, providing direct evidence of a hidden ocean. These moons, along with others like Ganymede and Callisto, also of Jupiter and Titan of Saturn, form a diverse group of worlds that challenge our understanding of habitability. Each one offers unique insights into the potential for life beyond Earth. The search for life in these subsurface oceans is a collective endeavor, driven by a sense of discovery and curiosity. Scientists use a variety of tools and techniques to study these distant worlds. Remote sensing from spacecraft, such as the Galileo mission to Jupiter and the Cassini mission to Saturn, has provided valuable data. Future missions, like the Europa Clipper and JUICE, Jupiter Icy Moons Explorer, aim to delve deeper into the mysteries of these icy moons. The data collected from these missions will help scientists understand the composition, dynamics, and potential habitability of subsurface oceans. It is a testament to human ingenuity and our relentless pursuit of knowledge. Umbriel, with its enigmatic nature, adds to the tapestry of these icy worlds. While it may not be as well studied as some of its counterparts, its potential for harboring a subsurface ocean cannot be ignored. The collective effort to explore and understand these moons is not just about finding life. It is about expanding our horizons, pushing the boundaries of our knowledge, and uncovering the secrets of the outer solar system. Each discovery brings us one step closer to answering the fundamental question: are we alone in the universe? Titania, a frozen world with a liquid core. In the cold, distant reaches of our solar system, beneath the icy surfaces of several moons, scientists have found compelling evidence of hidden oceans. These subsurface oceans, nestled beneath thick layers of ice, have sparked immense interest in the scientific community, particularly in the quest to find extraterrestrial life. Among these intriguing worlds, Titania, one of Uranus' largest moons, stands out due to its unique characteristics and the potential it holds for harboring life. Titania is a frozen world, its surface a stark landscape of craters and canyons, all blanketed in a thick layer of ice. Yet, beneath this icy exterior, there lies a tantalizing possibility: a liquid core. This hypothesis is supported by data from Voyager 2, which suggested that Titania might have a differentiated interior with a rocky core and an icy mantle. The presence of a liquid core, even if it's a briny, salty ocean, would be a significant discovery. It would mean that Titania joins the ranks of other moons like Europa, Ganymede, and Enceladus, which are also believed to have subsurface oceans. The potential for life in these hidden oceans is a topic of much debate and excitement. On Earth, life thrives in even the most extreme environments, from the depths of the oceans to the hottest of springs. If similar conditions exist in the subsurface oceans of these moons, it's not too far-fetched to imagine that life could have found a way to exist there as well. The key to this possibility lies in the presence of liquid water, a necessary ingredient for life as we know it. Moreover, the interaction between the rocky core and the ocean could potentially provide the necessary energy and nutrients for life to emerge and thrive. Our understanding of these icy moons and their hidden oceans is still in its infancy. Each new discovery, each new piece of data, brings us one step closer to unraveling the mysteries of these distant worlds. It's a journey of collective discovery, one that involves scientists from all over the world, working together to push the boundaries of our knowledge. And who knows, perhaps one day, we might find that we are not alone in the universe, that life exists not just on Earth, but also in the hidden oceans of the outer solar system. Until then, the search continues, fueled by curiosity, driven by the quest for knowledge, and inspired by the tantalizing possibility of finding life beyond Earth. Oberon, the outermost moon with a secret. In the frigid expanse of the outer solar system, where the sun's warmth is but a distant memory, a collection of moons orbit the gas giants, each harboring a secret that has captivated scientists and space enthusiasts alike. Among these celestial bodies, Oberon, the outermost moon of Uranus, stands as a silent sentinel, its icy surface concealing a potential subsurface ocean. This hidden sea, if it exists, would join the ranks of other suspected subsurface oceans in our solar system, such as those on Europa, Ganymede, Callisto, and Enceladus. The presence of these oceans has sparked a sense of collective discovery, a shared human endeavor to uncover the mysteries of our cosmic neighborhood and the potential for life beyond Earth. The idea of subsurface oceans on these moons is not mere speculation. It is grounded in scientific observations and models. For instance, the tidal forces exerted by their parent planets cause these moons to flex and heat up, a process known as tidal heating. This heat can melt ice, creating subsurface oceans. Moreover, the presence of certain features on their surfaces, like the geysers on Enceladus and the chaotic terrain on Europa, strongly suggest the existence of liquid water beneath. Oberon, with its ancient, heavily cratered surface, may not show such obvious signs. However, its location within Uranus's magnetosphere exposes it to charged particles that could potentially penetrate its surface and interact with any subsurface ocean, creating unique chemical signatures that future missions could detect. The potential for life in these hidden oceans is a tantalizing prospect. Life, as we know it, requires three key ingredients: liquid water, a source of energy, and certain chemical building blocks. Subsurface oceans could provide the first two, with hydrothermal vents on their ocean floors potentially serving as energy sources, much like they do on Earth. As for the chemical building blocks, recent studies have shown that the outer solar system is rich in organic compounds, which are the precursors to life as we know it. The discovery of these compounds on comets and in the atmospheres of outer solar system bodies suggests that they could also be present in subsurface oceans. While the existence of life in these oceans remains purely speculative, the possibility alone is enough to fuel our collective curiosity and drive our exploration of the outer solar system. The exploration of these moons and their potential subsurface oceans is not just a scientific endeavor, but a human one. It is a testament to our insatiable curiosity and our desire to understand our place in the cosmos. Each new discovery, each new piece of data, brings us one step closer to answering that fundamental question: are we alone in the universe? The journey is long, and the challenges are many, but the potential rewards are immeasurable. After all, the discovery of life beyond Earth would be one of the most profound moments in human history, a moment that would change our understanding of ourselves and our universe forever. So, as we continue to explore the hidden oceans of the outer solar system, we do so not just as scientists, but as explorers, pioneers, and dreamers. The moons of Neptune, a realm of ice and mystery. Neptune's moons, those distant and enigmatic worlds, have long captivated scientists and dreamers alike. Among them, Triton, Proteus, and the lesser-known Nereid, Larissa, and Hippocamp hold secrets that could rewrite our understanding of life in the cosmos. These icy bodies, bathed in the faint light of the outer solar system, may harbor subsurface oceans hidden beneath their frozen crusts. The potential for these oceans to support life is a tantalizing prospect, one that fuels our collective curiosity and drives us to explore further. Triton, Neptune's largest moon, is a particularly intriguing candidate. Its retrograde orbit suggests it didn't form around Neptune, but was instead captured by the planet's gravity. This violent past may have contributed to the internal heating that could sustain a subsurface ocean. Triton's surface is geologically active, with geysers spewing nitrogen gas and dust into its thin atmosphere. This activity hints at a complex interplay between the moon's interior and its surface, a dance that could create conditions suitable for life. The possibility of a hidden ocean, warmed by tidal forces and protected from harsh radiation, makes Triton a prime target for future exploration. Proteus, Neptune's second-largest moon, is a more enigmatic world. Its surface is heavily cratered, suggesting a lack of geological activity. Yet, like Triton, it may harbor a subsurface ocean. The evidence is circumstantial, but the potential is there. Nereid, another of Neptune's moons, has an eccentric orbit that takes it far from the planet before bringing it close again. This extreme journey subjects the moon to intense tidal forces, which could generate heat and potentially create a subsurface ocean. Larissa and Hippocamp, smaller and less understood, also hold secrets. Their proximity to Neptune means they are subjected to intense tidal forces, which could similarly lead to the formation of hidden oceans. The search for life in these hidden oceans is not just about finding extraterrestrial organisms. It's about understanding our place in the universe, about discovering whether life is a rare fluke or a common occurrence. Each moon, with its unique characteristics and potential for a subsurface ocean, offers a new piece of the puzzle. As we continue to explore, as we send probes and telescopes deeper into the outer solar system, we edge closer to answering these profound questions. The moons of Neptune, those icy worlds of mystery, are not just distant specks of light. They are beacons of hope, guiding us towards a future where we may finally understand the true extent of life in the cosmos. Triton, Neptune's captured moon with a subsurface sea. In the cold, dark expanse of the outer solar system, a silent revolution is unfolding. Beneath the icy surfaces of several moons, scientists have found compelling evidence of subsurface oceans. These hidden seas, warmed by tidal forces and possibly by radioactive decay, have sparked a wave of excitement and curiosity. Among these intriguing worlds, Triton, Neptune's largest moon, stands out. It's believed to be a captured Kuiper Belt object, a wanderer that was snagged by Neptune's gravity. This icy moon, with its retrograde orbit and geologically active surface, hides a secret, a subsurface ocean that could be as vast as those on Earth. The potential for life in these alien seas is a tantalizing prospect. On Earth, life thrives in even the most extreme environments, from the depths of the oceans to the hottest springs. If life can exist in such harsh conditions here, why not on these distant moons? Triton's subsurface ocean, shielded from the harsh radiation of space, could provide a stable environment for life to emerge and evolve. The same could be said for other moons like Europa, one of Jupiter's largest satellites, and Enceladus, a tiny moon of Saturn. Both are believed to harbor subsurface oceans, and both have shown signs of hydrothermal activity, a key ingredient for life as we know it. The discovery of these hidden oceans has fueled a sense of collective discovery and wonder. Scientists, using data from missions like Voyager 2, Galileo, and Cassini, have pieced together a picture of these alien worlds that is both familiar and alien. The oceans, locked beneath thick layers of ice, are a testament to the resilience of water in the face of extreme cold. They also raise tantalizing questions about the prevalence of life in the universe. If life can exist in these harsh, distant environments, then perhaps it's not so rare after all. The search for life in these subsurface oceans is not just a scientific endeavor, but a journey of discovery that could redefine our place in the cosmos. Proteus, a moon of contrasts and hidden depths. Proteus, the second largest moon of Neptune, is a world of stark contrasts and intriguing mysteries. Its surface is heavily cratered, ancient, and marked by chasms that hint at a violent past. Yet, beneath this icy exterior, scientists suspect a hidden ocean of liquid water might exist. This subsurface ocean, if it indeed exists, would be locked away in the moon's interior, shielded from the harsh radiation and extreme cold of the outer solar system. Proteus is not alone in this regard. Several other moons in our solar system, such as Europa, Ganymede, and Enceladus, are also believed to harbor subsurface oceans, making them prime targets in the search for extraterrestrial life. The potential for life on Proteus and other icy moons is a tantalizing prospect. These hidden oceans could provide the necessary ingredients for life as we know it: liquid water, energy sources, and the right chemical building blocks. On Earth, life thrives in even the most extreme environments, from deep-sea hydrothermal vents to Antarctic lakes sealed beneath ice sheets. If similar conditions exist on Proteus, there's a chance that life could have emerged there as well. The discovery of even simple microbial life on one of these moons would be a groundbreaking event, reshaping our understanding of biology and our place in the universe. Exploring these distant worlds is a collective endeavor, driven by our shared curiosity and the desire to answer fundamental questions about life in the cosmos. Missions like NASA's Europa Clipper and ESA's JUICE, Jupiter Icy Moons Explorer, are set to investigate the icy moons of Jupiter, while future missions to Neptune and its moons, including Proteus, are being planned. Each new discovery, each tantalizing clue, brings us one step closer to understanding whether we are alone in the universe. The journey is long, and the challenges are immense, but the potential rewards are beyond measure. Together, we stand on the cusp of a new era of exploration, poised to uncover the secrets of these hidden oceans and, perhaps, the secrets of life itself. The Kuiper Belt, a graveyard of ancient ocean worlds. Beyond the orbit of Neptune lies a vast, icy expanse known as the Kuiper Belt. This region is a relic from the early solar system, a graveyard of ancient ocean worlds that never had the chance to coalesce into full-fledged planets. Among these frozen bodies, some harbor a secret: subsurface oceans hidden beneath thick layers of ice. These oceans, kept liquid by the heat of radioactive decay and tidal forces, have captivated scientists and fueled speculation about the potential for extraterrestrial life. Several moons in the outer solar system are thought to possess these hidden oceans. Europa, one of Jupiter's moons, is a prime example. Its icy surface is crisscrossed with cracks and ridges, evidence of the subsurface ocean that lies beneath. Ganymede, another of Jupiter's moons, is the largest moon in the solar system and also likely harbors a subsurface ocean. Saturn's moon Enceladus is a tiny powerhouse, spewing water vapor and ice particles from its south pole, a clear indication of a hidden ocean. Even some of the dwarf planets in the Kuiper Belt, like Pluto, show signs of a possible subsurface ocean. The potential for life in these oceans is a tantalizing prospect. On Earth, life thrives in even the most extreme environments, from the depths of the oceans to the hottest springs. If life can exist in such harsh conditions on our planet, it's not unreasonable to think it could exist in the subsurface oceans of these icy moons. Scientists are particularly interested in the chemical composition of these oceans. Europa's ocean, for instance, is thought to be in contact with the moon's rocky core, which could provide the necessary ingredients for life. The plumes of Enceladus contain organic compounds, hinting at the possibility of prebiotic chemistry. The study of these ancient ocean worlds is an ongoing journey of discovery. With each new mission and each new finding, we inch closer to understanding the potential habitability of these icy bodies. The Kuiper Belt, once thought of as a mere graveyard of ancient ocean worlds, is now seen as a potential cradle of life. It's a testament to the collective curiosity and ingenuity of humanity, our insatiable desire to explore and understand the universe around us. The hidden oceans of the outer solar system beckon, promising answers to some of our most profound questions about life and our place in the cosmos. Pluto, a dwarf planet with a heart of ice and water. Pluto, once considered the ninth planet from the Sun, now holds the title of the largest dwarf planet in the Kuiper Belt. Beneath its icy surface, Pluto harbors a subsurface ocean, a discovery that has sent ripples of excitement through the scientific community. This ocean, likely composed of a mix of water and ammonia, is kept in a liquid state by the heat generated from the decay of radioactive elements and the pressure exerted by the overlying ice. The presence of this hidden ocean was inferred from observations made by NASA's New Horizons spacecraft, which revealed a heart-shaped glacier on Pluto's surface, hinting at the complex geological activity driven by the subsurface ocean. Pluto is not alone in its icy embrace of hidden oceans. Several of its moons, including Charon, Nix, and Hydra, are also suspected to harbor subsurface oceans. Charon, Pluto's largest moon, shows signs of past geological activity, such as cryovolcanism, which could be fueled by a hidden ocean. The smaller moons, Nix and Hydra, exhibit irregular shapes and rotation patterns that suggest they might have formed from the debris of a massive impact, potentially concealing oceans beneath their surfaces. These moons, along with Pluto, form a fascinating system that invites further exploration and study. The potential for life in these hidden oceans is a tantalizing prospect. On Earth, life thrives in extreme environments, from deep-sea hydrothermal vents to icy polar regions. The subsurface oceans of Pluto and its moons, shielded from the harsh radiation of space and potentially rich in organic compounds, could provide similar havens for life. While no direct evidence of life has been found, the conditions present in these hidden oceans are not entirely dissimilar to those found in some of Earth's most extreme environments. This raises the intriguing possibility that life, if it exists, might have evolved in these icy worlds in ways that are entirely alien to us. The discovery of these hidden oceans has sparked a sense of collective discovery and wonder. Scientists and enthusiasts alike are drawn to the mystery and potential of these icy worlds. Each new finding adds a piece to the puzzle, bringing us closer to understanding the true nature of these distant bodies. The journey of exploration is far from over, and with each new mission and observation, we edge closer to unraveling the secrets of Pluto and its moons. The hidden oceans of the outer solar system beckon, promising a future of discovery and perhaps, one day, the answer to the age-old question, are we alone in the universe? Charon, Pluto's moon with a hidden past. In the frigid expanse of the outer solar system, where the sun's warmth is but a distant memory, a collection of icy moons orbit their respective planets, hiding a secret beneath their frozen surfaces. Among these, Charon, Pluto's largest moon, stands out with its unique characteristics and a past that's only now being unveiled. Charon is locked in a synchronous rotation with Pluto, always showing the same face to its parent body, much like our own moon does with Earth. This tidal locking has led to a shared orbit around a common center of gravity, a point known as the barycenter, which lies outside of Pluto itself. The Moon's surface is a tapestry of valleys, mountains, and a vast chasm that dwarfs the Grand Canyon, hinting at a complex geological history. Beneath Charon's icy exterior, scientists suspect there may be a subsurface ocean, a hidden reservoir of liquid water kept from freezing by the heat generated from the Moon's internal processes and the gravitational interactions with Pluto. This hypothesis is supported by observations from the New Horizons spacecraft, which revealed a surprisingly youthful surface, suggesting recent geological activity. Such activity is often driven by the presence of subsurface water. If confirmed, this ocean would join the ranks of other suspected subsurface oceans in the outer solar system, including those on Europa, Ganymede, Callisto, and Enceladus. The potential for liquid water is tantalizing, as it's a key ingredient for life as we know it. However, the extreme cold, lack of sunlight, and high radiation levels make the prospects for life challenging, though not impossible. The search for life in these hidden oceans is a collective endeavor, a journey of discovery that unites scientists and enthusiasts alike. Each new finding, each tantalizing clue, fuels our imagination and propels us further into the unknown. The outer solar system, once considered a cold and lifeless realm, is now a frontier of exploration, a place where the boundaries of habitability are being redrawn. Charon, with its hidden past and potential subsurface ocean, is a testament to this new era of discovery. It reminds us that even in the most unlikely of places, the secrets of the universe await, ready to be uncovered by those who dare to look. The journey is far from over, and with each step, we come closer to understanding our place in the cosmos. The Oort cloud, a reservoir of primordial ocean worlds. Far beyond the familiar planets and the Kuiper belt, the Oort cloud is a vast, spherical shell of icy objects that marks the outer boundary of our solar system. This distant reservoir is believed to contain trillions of comets and other icy bodies, some of which may harbor secrets about the early solar system. Among these, scientists speculate that there could be primordial ocean worlds, remnants from the time when the solar system was young and water was abundant. These ocean worlds, hidden beneath thick icy crusts, could hold clues to the origins of life and the potential for its existence elsewhere in the universe. Several moons in our solar system, such as Europa, Ganymede, and Enceladus, have already shown evidence of subsurface oceans. Europa, one of Jupiter's moons, is thought to have a global ocean beneath its icy surface, kept liquid by tidal heating from the gas giant. Ganymede, the largest moon in the solar system, also has a subsurface ocean, and it's even possible that it has multiple layers of ice and water. Enceladus, a moon of Saturn, has geysers that spew water vapor and ice particles into space, providing strong evidence of a subsurface ocean. These discoveries have sparked excitement and curiosity about the potential for life in these hidden oceans. The Oort cloud's primordial ocean worlds, if they exist, could be even more intriguing. These objects have remained largely undisturbed since the solar system's formation, preserving a snapshot of the early conditions. The icy bodies in the Oort cloud are thought to be rich in organic compounds, the building blocks of life. If these objects also have subsurface oceans, they could provide a unique environment where life might have had the chance to emerge and evolve. The study of these primordial ocean worlds could offer insights into the early stages of life's development and the potential for life to exist in similar environments throughout the universe. The search for life in these hidden oceans is a collective endeavor involving scientists, engineers, and space agencies from around the world. Missions like NASA's Europa Clipper and ESA's JUICE, Jupiter Icy Moons Explorer, are set to explore the icy moons of Jupiter, while the Cassini mission has already provided valuable data about Enceladus. These missions are paving the way for future exploration of the outer solar system and the Oort cloud. As we continue to uncover the secrets of these distant worlds, we are not just exploring the outer reaches of our solar system, but also the very nature of life itself. The journey is filled with challenges, but the potential rewards are immense, driving us forward in our quest for knowledge and discovery. The search for extraterrestrial life, following the water. In the cold, distant reaches of our solar system, far from the warmth of the sun, a surprising discovery has captivated scientists and space enthusiasts alike. Beneath the icy surfaces of several moons, there's compelling evidence of subsurface oceans. These hidden bodies of water have sparked immense interest, primarily because they represent potential habitats for extraterrestrial life. The presence of liquid water is a crucial ingredient for life as we know it, making these icy moons some of the most promising places to search for life beyond Earth. Among the most intriguing candidates are Jupiter's moon Europa and Saturn's moon Enceladus. Europa, slightly smaller than our own moon, is believed to harbor a global ocean beneath its icy crust. This ocean may contain more than twice as much water as all of Earth's oceans combined. Enceladus, a tiny moon compared to Europa, has geysers that spew water vapor and ice particles into space, providing strong evidence of a subsurface ocean. These geysers also contain organic compounds, which are the building blocks of life. The collective discovery of these features has sent waves of excitement through the scientific community. The search for life in these hidden oceans is not just a shot in the dark. It's a calculated endeavor based on our understanding of life's requirements. Water, of course, is a fundamental necessity, but these oceans also offer other promising conditions. Europa's ocean, for instance, is likely in contact with a rocky seafloor, which could provide essential minerals and energy sources for life. Similarly, the heat generated by tidal forces on Enceladus could create hydrothermal vents, much like those found on Earth's ocean floors. These vents support thriving ecosystems, even in the absence of sunlight. The journey to explore these oceans is just beginning. Missions like NASA's Europa Clipper and ESA's JUICE, Jupiter Icy Moons Explorer, are set to study these icy moons in greater detail. They aim to confirm the presence of these subsurface oceans, assess their habitability, and perhaps even find signs of life. The collective effort of these missions represents a significant step in our quest to answer one of humanity's most profound questions. Are we alone in the universe? The hidden oceans of the outer solar system may well hold the answer. The technology of exploration, probes, and rovers. In the frigid expanse of the outer solar system, several moons harbor a tantalizing secret: vast subsurface oceans hidden beneath their icy crusts. These oceans, kept liquid by tidal forces and the decay of radioactive elements, have sparked immense interest in the scientific community. Europa, one of Jupiter's largest moons, is a prime example. Beneath its icy surface, a global ocean of liquid water is believed to exist, potentially containing more than twice the volume of Earth's oceans. Similarly, Enceladus, a tiny moon of Saturn, spews geysers of water vapor and ice from its south polar region, strong evidence of a subsurface ocean. Ganymede, Jupiter's largest moon, also likely harbors a substantial body of liquid water beneath its icy crust. These moons, along with others like Callisto and Titan, offer compelling targets in the search for extraterrestrial life. Exploring these hidden oceans presents significant challenges due to the extreme distances and harsh conditions. Probes and rovers, the workhorses of modern space exploration, are at the forefront of this endeavor. The Galileo mission, which orbited Jupiter from 1995 to 2003, provided crucial data about Europa's magnetic field and the likely presence of a subsurface ocean. The Cassini spacecraft, which studied Saturn and its moons until 2017, captured stunning images of Enceladus's geysers and analyzed their composition, revealing the presence of organic molecules. These missions laid the groundwork for future exploration, demonstrating the potential for life in these distant, icy worlds. Future missions aim to delve even deeper into these mysteries. NASA's Europa Clipper, set to launch in the coming years, will perform multiple flybys of Europa to gather detailed measurements of its ice shell, ocean, and geology. The European Space Agency's JUICE, Jupiter Icy Moons Explorer, mission, also en route, will focus on Ganymede, Callisto, and Europa, studying their subsurface oceans and potential habitability. For Enceladus, the proposed Enceladus Orbalander mission could one day land on the moon's surface, collecting samples from its plumes to search for signs of life. These missions represent the collective efforts of scientists and engineers worldwide, driven by the shared goal of understanding the potential for life beyond Earth. The technology behind these probes and rovers is nothing short of remarkable. They are equipped with a suite of sophisticated instruments designed to withstand the harsh conditions of the outer solar system. Cameras capture high-resolution images, while spectrometers analyze the composition of surface materials and plumes. Radar systems penetrate the icy crusts to map subsurface structures. Advanced communication systems relay data back to Earth, often over vast distances. The development of autonomous navigation and AI-driven data analysis further enhances their capabilities, allowing them to make real-time decisions and adapt to unexpected discoveries. This technological prowess is a testament to human ingenuity and our relentless pursuit of knowledge. The future of outer solar system exploration. Beyond the familiar realms of the inner solar system, a collection of icy moons orbit gas giants, harboring secrets that could rewrite our understanding of life in the universe. These celestial bodies, such as Europa, Ganymede, Callisto, and Enceladus, are thought to conceal vast subsurface oceans beneath their frozen surfaces. The presence of liquid water, a key ingredient for life as we know it, has sparked immense interest and excitement within the scientific community. These oceans, shielded from the harsh radiation of space by their icy crusts, offer potentially habitable environments that could support life. The potential for life on these moons is not merely speculative. For instance, Europa, Jupiter's moon, exhibits plumes of water vapor erupting from its surface, suggesting active exchange between the subsurface ocean and the exterior environment. Similarly, Enceladus, a moon of Saturn, spews icy particles and water vapor into space, with evidence pointing to a subsurface ocean that could be habitable. The chemical composition of these plumes, including the presence of organic molecules, further fuels the possibility of life. Scientists are eager to explore these environments, not just to search for life, but to understand the conditions that might support it. The future of outer solar system exploration is poised to be a collective journey of discovery. Missions like NASA's Europa Clipper and ESA's JUICE, Jupiter Icy Moons Explorer, are set to revolutionize our understanding of these icy worlds. These missions aim to study the moon's compositions, geologies, and potential habitability in unprecedented detail. Moreover, the development of advanced technologies, such as autonomous underwater vehicles and sophisticated ice-penetrating radar, will enable us to delve deeper into these alien oceans. The data collected will not only shed light on the potential for life in our own solar system, but also inform our search for habitable exoplanets beyond. Collaboration is key to unlocking the mysteries of these hidden oceans. International partnerships, such as the one between NASA and ESA, facilitate the sharing of resources, expertise, and data, accelerating the pace of discovery. Public engagement and support are also crucial, as they fuel funding and enthusiasm for these ambitious missions. As we stand on the brink of this new era of exploration, the collective effort of scientists, engineers, and enthusiasts worldwide will drive us forward, unraveling the secrets of the outer solar system and perhaps redefining our place in the universe. The journey ahead is filled with challenges, but the potential rewards, answering the age-old question of whether we are alone in the universe, are immeasurable. The ethical implications of exploring hidden oceans. Beneath the icy crusts of several moons in our outer solar system, scientists have discovered vast, hidden oceans. Europa, one of Jupiter's largest moons, is believed to harbor an ocean beneath its icy surface, potentially containing twice as much water as Earth's oceans. Ganymede, another of Jupiter's moons, is thought to have a subsurface saltwater ocean, possibly nestled between two layers of ice. Enceladus, a moon of Saturn, has geysers that spew water vapor and ice particles, indicating a subsurface ocean. Titan, Saturn's largest moon, is suspected to have a liquid water and ammonia ocean under its icy crust. These hidden oceans have sparked immense interest, not just for their scientific value, but also for the potential they hold for extraterrestrial life. The presence of liquid water is a crucial ingredient for life as we know it. Where there's water, there could be life. This makes these subsurface oceans prime targets in the search for extraterrestrial life. The oceans on these moons are likely in contact with rocky material, which could provide essential chemicals for life. Moreover, hydrothermal vents on the ocean floors could create environments similar to those on Earth where life first emerged. The discovery of even microbial life in these oceans would be a groundbreaking event, reshaping our understanding of life in the universe. It would also raise profound questions about our place in the cosmos and the potential for life elsewhere. Exploring these hidden oceans presents a unique set of ethical implications. One of the primary concerns is the potential for contamination. Both forward contamination, where Earth microbes hitch a ride to these moons, and backward contamination, where extraterrestrial life is brought back to Earth, pose significant risks. To mitigate these risks, strict planetary protection protocols are in place. These include sterilizing spacecraft and avoiding certain areas, like the plumes of Enceladus, to prevent contamination. However, as we venture deeper into these oceans, these protocols may need to be revisited and updated. Another ethical consideration is the potential impact on any existing life forms. We must tread carefully to avoid harming or disrupting any ecosystems that might exist. This requires a delicate balance between scientific curiosity and responsible exploration. The collective discovery of these hidden oceans is a testament to human ingenuity and our insatiable curiosity. It's a journey we're on together as a species. Each new finding, each new mission, brings us one step closer to answering some of life's most profound questions. Yet, with each step, we must also consider the ethical implications. We must explore responsibly, ensuring that our quest for knowledge does not come at the expense of potential life forms or our own planet. It's a challenge, but one that we're rising to meet. After all, the search for life beyond Earth is not just a scientific endeavor. It's a journey that touches on the very essence of what it means to be human. The cultural impact of discovering extraterrestrial oceans. In the outer solar system, beneath the icy crusts of several moons, scientists have discovered vast subsurface oceans. Europa, one of Jupiter's largest moons, is believed to harbor an ocean beneath its icy surface, potentially containing more than twice as much water as all of Earth's oceans combined. Ganymede, another of Jupiter's moons, is thought to have a saltwater ocean, possibly nestled between two layers of ice. Enceladus, a moon of Saturn, has geysers that spew water vapor and ice particles into space, strong evidence of a subsurface ocean. Titan, Saturn's largest moon, is also suspected to have a liquid water ocean beneath its icy crust. These discoveries have sparked immense excitement and speculation about the potential for extraterrestrial life. The presence of liquid water is a crucial ingredient for life as we know it. Where there's water, there could be life. This possibility has captivated scientists and the public alike, fostering a sense of collective discovery and shared wonder. The idea that we might not be alone in the universe has profound implications for our understanding of life, the cosmos, and our place within it. It's a thrilling prospect that unites people across cultures and disciplines, driving us to explore further and push the boundaries of our knowledge. This collective fascination has permeated popular culture, inspiring countless books, movies, and artworks. The discovery of these hidden oceans has fueled our imagination, leading to stories of alien life forms, underwater civilizations, and interstellar exploration. It's not just scientists who are captivated by these icy moons. Artists, writers, and filmmakers are drawn to the mystery and potential of these distant worlds. The cultural impact is evident in the way these discoveries have become a part of our collective consciousness, shaping our dreams and aspirations. Moreover, the search for life beyond Earth has united people in a shared quest for knowledge. It's a testament to human curiosity and our innate desire to explore the unknown. The discoveries of subsurface oceans have given us a new perspective on our own planet and our place in the universe. They remind us that we are part of a vast and interconnected cosmos, and that the search for life is a journey that transcends borders and boundaries. It's a journey that we embark on together, driven by a shared sense of wonder and a collective desire to understand the mysteries of the universe. The art of imagining alien seas. Beneath the icy crusts of several moons in the outer solar system, scientists have strong evidence of subsurface oceans. Europa, one of Jupiter's largest moons, is believed to harbor a global ocean beneath its icy surface, potentially containing more liquid water than all of Earth's oceans combined. Ganymede, another of Jupiter's moons, is thought to have a saltwater ocean beneath its icy crust, which could be up to 65 miles deep. Enceladus, a moon of Saturn, has geysers that spew water vapor and ice particles into space, indicating the presence of a subsurface ocean. Titan, Saturn's largest moon, is also suspected to have a subsurface ocean of liquid water and ammonia. These hidden oceans have sparked considerable interest in the scientific community due to their potential to support life. The idea of alien seas is not just a figment of science fiction. It is a tangible possibility that drives our exploration of the outer solar system. The presence of liquid water, a key ingredient for life as we know it, raises the tantalizing prospect of finding extraterrestrial life forms. The conditions in these subsurface oceans could be similar to those found in Earth's deep-sea hydrothermal vents, where life thrives in extreme conditions. The discovery of even microbial life in these alien seas would have profound implications for our understanding of life in the universe. It would suggest that life could exist in a variety of environments, not just on the surface of planets. The search for life in these hidden oceans is a collective endeavor. Scientists from around the world collaborate on missions to explore these moons, sharing data and insights. The Europa Clipper mission, for instance, is a planned NASA mission to study Europa's habitability. It will perform flybys of the moon to gather detailed measurements and images. Similarly, the European Space Agency's JUICE mission, Jupiter Icy Moons Explorer, aims to explore Jupiter's icy moons, including Ganymede, Callisto, and Europa. These missions represent a significant step forward in our quest to understand these alien seas and their potential for life. The data collected could provide valuable insights into the conditions necessary for life to exist beyond Earth. The art of imagining alien seas is not just about speculation. It is about using our knowledge of Earth's oceans and the conditions for life to make educated guesses about what might exist in these hidden worlds. Scientists consider factors such as the chemical composition of the oceans, the presence of energy sources, and the stability of the environment. They also look for signs of geological activity, which could indicate the presence of hydrothermal vents or other features that might support life. The process is a blend of scientific rigor and creative thinking, as researchers strive to push the boundaries of our understanding. Each new discovery brings us closer to answering one of humanity's most profound questions: are we alone in the universe? As we wrap up our journey through the hidden oceans of the outer solar system, let's take a moment to reflect on the incredible discoveries we've explored. We ventured beneath the icy crusts of moons like Europa, Ganymede, Callisto, and Enceladus, where vast oceans of liquid water hide from view. We've marveled at the geysers of Enceladus, the chaotic terrain of Europa, and the magnetic field of Ganymede, all clues pointing to the potential for these worlds to harbor life. Imagine, just for a moment, the thrill of standing on the surface of one of these moons, knowing that beneath your feet lies an ocean that could be teeming with life. It's a prospect that fills us with awe and excitement, a testament to the boundless possibilities that lie within our solar system. But this is just the beginning. Our understanding of these hidden oceans is still in its infancy, and there's so much more to explore. Future missions, like NASA's Europa Clipper and ESA's JUICE, will provide us with unprecedented data, bringing us closer to answering the age-old question: are we alone in the universe? So, let's keep our eyes on the skies and our hearts open to the possibilities. Who knows what wonders await us in the hidden oceans of the outer solar system? Join us on this ongoing journey of discovery, and together, let's uncover the secrets of our incredible cosmic neighborhood. Until next time, keep exploring, keep dreaming, and keep reaching for the stars.